Uh, so this is group 17. I'm Sandesh Pokhrel, and we have Chandrakant Bogra and Venkata Naveen Gadde. Today we're going to be talking about severe weather avoidance using informed heuristic search and comparative analysis of search algorithms. So let me introduce severe weather avoidance using informed heuristic search. I'll move the slide. So atmospheric processes are important because weather is an important factor in aviation. Weather issues influenced around 21.75% of accident in general aviation category in 1990. 25.9% of all fatal accidents were weather related in same time. So we can see how weather influences aircraft. Concept of free flight and importance of reliable and fast weather avoidance algorithm has been apparent in these few decades. With free flight, a pilot can decide the starting and ending point for a route depending on the weather. So the pilot would require reliable and fast weather avoidance algorithm, so they don't have to figure out the route and let the algorithm do it. There has been different developments in regards to aviation accidents, but the one we'll be focusing on is a search algorithm. Next slide. So first we're gonna go into weather information. So any type of weather that is gonna cause destruction is called severe weather. So it has to be able to damage the aircraft that we're focusing on, and what we want to do, what our goal state is that we want to avoid reasons with these weather conditions. So some of the important data information that the pilot would need to avoid this kind of weather is radar reflectivity, wind speed and direction, turbulence, and icing severity and temperature. So here we have information on radar data for detection of intensity of thunderstorm, and we're going to be using the 2D Gaussian function. Will help us simulate radar image by showing thunderstorm induced weather intensity in XY point. We'll also have to repeat this function for different thunderstorms, so we have data that is closer to reality. And then the researchers here utilized figure 1 as an example to work with the algorithm, and then they have this table 1 where they give us information on intensity and intensity or radar reflectivity and color that denotes that intensity. So any airplane should not go through regions that have intensity of 30 dBz and more. And so yellow and red regions aren't safe for aircraft. So we want the aircraft to avoid those regions because of the weather intensity. Even the data provided here are sometimes inaccurate though. So this is not 100% reliable because there are factors such as precipitation attenuation, accumulation of ice on radar, and then ground clutter and other influences that can affect the algorithm's results. Next one. So the algorithm they've utilized here is a search algorithm. So a search algorithm is considered to be an informed heuristic search technique which targets minimum total path cost denoted by F. So this algorithm considers the function f for nodes in the tree. The evaluation function is formed by g, the actual cost for getting to node n, h, estimated cost of path from node n to goal state, and with f, g, and h, we have the equation fn equals gn plus hn. Um, the benefit of choosing this algorithm is that it will discover solution for any solvable issue and additionally find the best solution there is. However, this algorithm also has issues because it requires a lot of time and memory. So, and that's it. You can stop the recording. Oh, okay, you can continue. Developing the weather avoidance algorithm has like some constraints too. Flight path needs to be short and limit itself to constraints created by threshold comfort level, pilot workload, and aircraft physical limitations. Which means we can't just choose a route without taking these factors into consideration. So like we need to take constraints like minimum segment length, which is the distance from one vertex to another along the flight path, must be greater than or equal to a predetermined minimum distance. So this would lead to reduction in pilot's workload. Another thing we need to consider is maximum turning angle. The flight path turn should have heading changes of less than 60 degree, and it should never go beyond 90 degree, because like going beyond 90 degree is like difficult for the pilot while making a turn. And minimum number of turns, like the flight path requires piecewise linearity with paths having fewest turns possible, which would again reduce the workload for the pilot. We don't want to burden the pilot. So these are the constraints that would help out the pilot and also take aircraft's physical limitations into consideration. Okay.
So coming to the thunderstorm avoidance algorithm, this algorithm is used by uh, pilots to check the correct shortest path between 2 points when the weather is severe. Weather is severe means there are thunderstorms in the path along the direction of the 2 points. So coming to the algorithm, to begin with the algorithm, the map is divided into several grids. The size of these grids can be bigger than the radar image, or it can be the same size of the radar image. If the grid size is greater than the radar image, the intensity of each grid is set to the maximum intensity that is found in the area of the grid. So if the region in thunderstorm avoidance algorithm, there are some constraints. If the intensity of the grid is greater than 25, the map is set to be inaccessible. Means the map is set to the red color position, which you will be seeing in the next slides, so that the aeroplane cannot pass through that map. And coming to the steps, there are certain uncertainties and inaccuracies in the radar image, because of the shortest path we cannot take the direct straight line between 2 points. So there is a search tree between the two parts, so that no node can be generated in the inaccessible region, and there is a length that is to be determined in the inaccessible region, because there is certain length for the aeroplane to take some turns for the turning angle and the minimum number of turns also. Depending upon the minimum chosen length and the number of turns that are allowed in the flight path, the segment is divided into certain K segments. Along each segment, a perpendicular line is drawn to the original path between the 2 points, that is the shortest path, and the nodes are chosen along those lengths. The extent of the inaccessible region and the specified maximum turning angle determine the two limits within which the nodes can be picked, such that the next point to the heading of the aeroplane can be fixed by the inaccessible region. it does not goes into the region. And this is one of the example of an thunderstorm coming to. If you can see figure 4, this is the radar image that is taken, and 1 and 2 are the start point and the end point. uh, if you see here, the red region is the inaccessible region, that is the area which has more than 25 decibels of uh, in uncertainty. And if you see the case 5, it is also same thing. The the path between 2 points goes through the thunderstorm. If you see the figure 6, it is the path goes slightly deviated from the thunderstorm. This is the path founded uh, by the algorithm. And if you see figure 7, this is a flight path by the radar image after the algorithm. When the radar it is recorded by the radar image. So if you see in the figure 6, the flight takes one two three turns, and it has three minimum segments. So it is like that. It is the shortest path as approved by the algorithm. So, coming to the algorithm stability, the algorithm was tested on too many cases. The algorithm fails to compute a safe shortest path if the starting point and the ending point lies in the thunderstorm region. Because if the starting and the ending point lies, or the ending point lies in thunderstorm, the algorithm cannot deviate, come out from the thunderstorm region because of the intensity of the area. The algorithm always finds to uh, find a solution in the forward direction. If the algorithm is flanked by a thunderstorm, the forward direction heading will be unstable and it will be unable to retrace the thunderstorm. The algorithm does not permit heading changes greater than the maximum turning angle, because if there is sharp turns to the aeroplane, the pilots cannot handle the turns, and the number of length and the length of the distance also increases. If the starting point of is too close to the thunderstorm and thunderstorm stretches far on both sides, it is not produce satisfactory results, because if the starting point is too close to the thunderstorm, it cannot go back, as this algorithm always only chooses a path in forward direction. It cannot trace back the path of the flight. And the algorithm works well within a small area, because when it comes to be when it comes to a large ratio of map, the thunderstorm also has several factors, such as the weather condition in one area is different from another area, and the thunderstorm, it expands on a rapid way. The algorithm should have capability to generate smooth and feasible turns, because if the algorithm generates sharp turns and uh, more number of turns, the pilot will be very much tends to take the turns, and there will be a lot of fuel loss. And the search tree has finite depth, and depth can be determined by the number of turns allowed in the flight path, because there are certain constraints to the flight path, the distance and the journey. The depth should be correct, and this is to be there. I've start.
Go ahead.
AI relation with other fields. Uh, uh, Artificial intelligence, machine learning, language processing, deep learning. Artificial intelligence. Artificial intelligence leverages computer and machines to mimic the problem solving and decision making capabilities of the human mind. Machine learning. Machine learning is the field of study that gives computer the capability to learn without being explicitly programmed. In this computer, learn from its experience. Language processing. Natural language processing, the branch of artificial intelligence, concerns with given computers ability to understand text and spoken to words in much the same way human beings can. Next, deep learning. Deep learning is a type of a machine learning based and ANN in which multiple layers of processing are used to extract progressively higher levels feature from the data. Uniform search. Uniform search algorithms do not have any additional information about state or state space other than how to traverse the tree. So it may called as blind search. So it has some examples of breadth first search and depth first search, uniform cost search. So it has some disadvantages, does not provide optimal solutions, require more number of steps. Informed search. Informed search, the informed search algorithms utilizes the problem specific knowledge in order to queue to the solution of the problem. It has some examples, A-star algorithm, best first search, A-star algorithm. It has some advantages, can provide optimal and complete solution, can solve very complex problems. Informed search, it has some BFS, DFS, breadth first search. Breadth first search is a graph traverse algorithm that start traveling the graph from root node and explore all the neighboring nodes. Complexity of OV plus E, V equal to number of nodes, E equal to number of edges. Depth first search. Depth first search starts at the root node of a tree and goes as far as it can down a given path, the backtrack until it finds an path and then explores it. Then complexity, O of E plus E, V equal to number of nodes, E equal to number of edges. Uniform cost search. Uniform cost search is an optimal solution to find the path from root node to the destination node with the lowest cumulative cost in a weighted search space, with each node has a different cost of a traversal. Uninformed search. It has best first search. It is the combination of the depth first search and breadth first search algorithms. It uses the Heuristic function and search. Complexity of n star log n equal to number of nodes, A star. A star is a version of the best first algorithm that is based off the use of Heuristic techniques to attain optimality and completeness. Complexity is O of B of D. Conclusion: informed search algorithms gives the most optimal solution that in ununiformed search algorithm. Ununiformed search algorithms are most time consuming algorithms. Blind search technique are less effective than heuristic search techniques. The informed search is more efficient and cost effective. Informed searches uses knowledge to find steps to the solution when blind searches does not have any basic knowledge. Informed search is highly efficient as consumes less time and cost. Thank you.